if I have like a 95 point something in physics, I'd have to get a pretty bad grade for this test to drop me like to a B, right?
I mean, I would think so. It would depend on what your last test grade was.
And you haven't pulled out the lowest quiz yet, right?
Correct.
Okay, good. That might
Virginia,
help a
you
little
graded
bit.
my second quiz wrong. I should have gotten a 95 because I got one of them wrong.
Oops. Sorry.
I did address that next time.
My bad.
Did you say that you had some, is this the one where you had some example that you said wasn't completed or something?
Indeed.
The thing where it says use the trapezoidal rule with n equals 4 to estimate the integral from 1 to 2 of x squared dx. Use the trapezoidal rule, TR, with n equal to 4 to estimate the integral from 1 to 2 of x squared dx.
Yes.
Okay.
That's it.
I'm just going to start there. And if you already have it, well, you can just get it again.
Like, you got pretty far into it too, but then, you didn't finish the thing.
Well, we'll just start over. Good refresher on all parts. All right, so obviously we can do this with NINT to see what that's equal to. But the first thing that we do is we will partition 1 to 2 into 4 subintervals. So that's what the n equals 4. It tells us how many subintervals we're going to have. So h equals 2 minus 1 over 4. So increments of 1/4 will be how we're doing that. So then 2, evaluate y equals x squared at each partition point. Just because I'm genuinely curious, I want to know if it can do this. This is, you don't need to write this. No, it cannot. Okay. I just wanted to know before I turned this off.
I hate it.
All right, so I'm going to have from 1 to 1 1/4, from 1 1/4, to 1 2/4, which obviously, yes, that is 1/2, but I'm going to leave it that way for a reason. From 1 1/2, well, I'm going to simplify it here. 1 1/2 to 1 3/4, and then 1 3/4 to 2. So this is just so that I can see all of these here that I've done it, basically. So then y of 5 over 4, which is this first one, is 5 over 4 squared. Didn't I not turn that thing off?
I think you did.
Go away. 25 over 16. Then y at 6 over 4, 6 over 4 squared, or 36 over 16. Then y of 7 over 4. The main reason for leaving them all over 4 instead of reducing is so that we already have the common denominator in the end. So this is 7 over 4 squared, which is 49 over 16.
I got so used to improper fractions that when writing the proper fractions, I would start writing the one half the length, and then I would remember, oh, I need to keep on going with that.
Remember I used to improper fractions? I was like, no, those are
I'm trying to get the 8th graders to understand improper fractions are okay, but they've been taught for so long that they're not okay, that they don't like them, and it's bugging them, and I'm like, just do it.
I would much rather do improper
used to be
fractions
like
than
that.
proper fractions.
Yes.
Proper fractions,
They just look prettier.
which do.
Well, and like mixed numbers, they're fine. And if there are certain things, it's better to have them as a mixed number or a decimal.
Not proper fractions, mixed numbers.
But I'm like, the amount of times that an improper fraction is just better, like, I don't know. Anyways, so we need the ends, and then we also need like the like endpoints of it. So I don't know at what point your notes stopped, but anyways, t equals
We're getting there.
1/4 over 2, because that's our formula for the trapezoidal rule, times
I'll let you know when it stopped.
1 plus 2. I'm just like waiting for him to randomly be like, stop!
It's coming soon.
I figured 2 times 25 over 16 plus 2 times 36 over 16 plus 2 times 49 over 16 plus
And
4.
that's
Yeah, I figured.
it. Just add that plus. You did not write 4.
Oh, it stopped at the 4. It's
It
so
stopped at
random.
plus.
Guess we'll never know.
Well,
Interesting.
Now I do originally, so take that.
So this is 1/8 times 16 over 16 plus 50 over 16 plus 72 over 16 plus 98 over 16 plus 64 over 16. So 1/8 times 300 over 16
Oh,
equals 75 over 32.
I guess 300 does make sense.
Now, as a decimal, we get 2.34375. Now, if you go back and do the original integral in NINT, you would get 2.3 repeating. So this would be the exact answer. This is an approximate. Because the trapezoidal rule is just approximating, essentially. So what we would do is we do the error. Which is 2.34375 minus 2.33 repeating divided by 2.33 repeating. .0044 rounds to 7. So that means there's approximately 0.447% error. Thank you. I was trying to get that out because I thought I was going to sneeze again. So this is an overestimate.
Overestimate looks really weird. Overestimate. I mean, I don't know. How would you say that?
Overestimate.
Overestimate. All right.
Overestimate.
You can tell you were thinking about that one for a while.
Yeah.
Use the trapezoidal rule with n equals 4. to approximate the value of the integral. Use the concavity of the function to predict whether the approximation is an overestimate or an underestimate. Finally, find the integral's exact value to check your answer. So basically, same thing we just did, but plus concavity. So the integral from 0 to 2
How many cavities do you have right now, Virginia?
of x squared dx
Oh, nice.
and n equals 4. So I'm from 0 to 2. So h would be 2 minus 0 divided by 4, which is 1/2.
I was so confused when you said that the interval is 0 to 2 because I wrote the integral from 0 to 4. And then I realized
Well, that would be wrong.
That's from 0 to 2.
So I'm going to make a little table here. Kind of the way I like to do these ones usually. Rather than like writing out every little interval that it's going to be. I just think this is easier. So 0, 1/2, 1, 3/2, and 2. Besides the 2 endpoints and then the intervals in the middle. So when I plug in 0, I get
You got this, Virginia.
Wait, hold on, I'm still making my table. The lines are not going straight.
She doesn't have lines.
Well, I have lines.
Virginia, help me.
Huh?
Josh doesn't know what 0 squared is.
0. I was gonna say something completely random just to like throw you guys off. Just like
You didn't make us think you-
All right, what about 1/2 squared?
1/4,
1 squared,
1
3/2 squared,
9/4,
2 squared.
4.
16/4.
Okay, Josh, don't be extra.
I'm always extra, you know this.
All right, part A. T equals 1/2, so h over 2, divided by 2, times 0 plus 2 times 1/4 plus 2 times 1 plus 2 times 9/4 plus 4 so that ends up being 1/4 times 1/2 plus 4/2. I'm just doing this to get the common denominator. Plus 9/2 plus 8/2. Yeah. So that ends up being 1/4 times 10, 22 divided by 2, 11. So then as a decimal, because ultimately we need decimals for this stuff, that would be, what, 11? Nope, not 11. I don't know why I just said 11. I was looking at 11.
Point something.
Yeah, I think it's 2.75.
I thought Virginia was about to say that. Because she said
It's
something that started with an S.
Yeah.
Well, she said.
I did say something.
All right, part B is use the concavity of the function to predict whether the approximation is an overestimate or an underestimate. So, what's the derivative of f?
You got this, Virginia?
Wait.
What's the derivative of this?
Am I doing it normal or is it that thing where I have to like add the 1 or?
It's
Derivative.
not the antiderivative.
Okay, just want to make sure I'm on the same page.
And the second derivative,
2.
which is greater than 0. So that means it's an overestimate. And then they want us to actually use, or well, find the integral's exact value. They don't say with NINT. So 0 to 2 of x squared dx. What's the antiderivative of that?
1/3 x cubed.
And then it's evaluated from 0 to 2. So 1/3 times 2 cubed. Obviously it would be minus 0, so I'm just not doing that part. So this would be 8/3, which is what?
2.668.
So pretty obvious that's an overestimate. All right, next one. Use the function values in the following table in the trapezoidal rule with n equals 6 to approximate the integral from 2 to 8 of f of x dx. So they give us n equals 6 in the integral from 2 to 8 of f of x dx. And then they give us this lovely table. That 8 is so much larger than everything else.
This is the big guy. Oh, well, it was.
16, 19, 17, 14, 13, 16, 20. I think I just broke Josh.
No, you did not break Josh. Josh was just trying to figure out how it went up and down and up, but Josh remembers that there are functions that do that.
Josh,
Josh had a light bulb moment.
and
Like Virginia's drink.
glowing in the sun.
Josh just doesn't remember which
I'm gonna pay for
function
that in like 20 years.
Probably.
Yeah.
What do you mean?
The fact that it's like
I'm
radioactive.
just gonna like, just shrivel up
die?
one day, just
You're already
The other day,
thinking
my
about
mom said
it.
something about, they were like, said, okay, so Kenny's aunt is retiring from the shipyard and she works in RadCon, so like radiology stuff. Anyways, like nuclear things. So then my mom was like, they should do her retirement party something radioactive. And then my mom looks and goes, isn't there a song about that? I was like, Mom.
She's probably heard it on the radio
Kenny goes,
500
oh no.
Well, the radio was active.
That song plays on the radio, like 9 out of 10 times you turn it on, that song's coming on.
That's funny. I don't know what channel you listen to. I never hear that song on the radio.
I always.
But I'm on country music, and I don't really think that's country, so.
Like in the mall or something. Like
Oh, well, yeah.
At Kohl's. Always hear that.
The other day when I was at Kohl's, I think it played, actually. That's probably why she thought about it.
Like, isn't there a song?
I was like, oh gosh, Mom.
Now it's gotta play.
All right, so when we're given the information like this, we have A is 2 and B is 8. So H is 8 minus 2 over 6. So H is 1. Which, in a sense, we didn't necessarily have to do that because they have already chunked it out for us. But I guess on occasion they may not have, so.
They may not have made a chunk for us.
And technically, just something I noticed, they actually write y as f of x because of how this was presented here, but it really doesn't matter. We obviously use those things interchangeably. So the first and last number always are just as they are. The other ones are all multiplied by 2. So t equals, this is just h is 1, so it's just 1/2 times 16 plus 2 times 19 plus 2 times 17 plus 2 times 14 plus 2 times 13 plus 2 times 16 plus 20.
I'm just gonna put in the C's instead of dots. I think I'd mix up where everything's supposed to go.
So I've got 1/2 times 16 plus 38 plus 34 plus 28 plus,
Where's the 1/2 come from?
because it's h over 2,
Okay.
so 1 over 2. Plus 32 plus 20.
Oh.
Somebody just died.
I wonder who it was. Depending on who it was, that might be concerned.
Probably a basketball player considering they're leaving.
Oh, that's right.
Only the girls, right?
Yes.
Okay, I might be more concerned then. It was one of the guys in the team, whatever.
So t equals 97. And that's all we have to do on these ones. Do y'all get to ride the bobsled?
No, I don't think so. I feel like we talked about that. I don't think we're doing it.
I can't remember last year if they said they were not going to reopen for that because the track was getting too used. Because 2 years ago it was closed because they were running trials for,
I thought you said child.
what was it? For the Olympics or something. I don't know. Anyways, and so they couldn't, or for like the Special Olympics or something, so they couldn't do it. And then another day, last year, there was something else going on. They actually were running like Olympic trials last year while we were there. It was kind of crazy. So we ended up doing something else there instead. So
Yeah.
I wasn't sure if y'all were going to get to again
I
or
think
not.
they said that they stop it in February or something. Like we'd be there 2
I
weeks.
think I think that is what they said.
Would have been cool to watch an Olympic trials, though.
Yeah.
It was Olympic trials for some sort of skiing, so you could only really see part of it, but it was like the cross-country skiing.
That'd be
That
cool.
sounds more interesting than some other things that might be there.
I don't even know what we're doing.
I
I
don't
barely even
either.
look at the schedule.
I haven't seen the schedule.
I'm just telling you, tubing at Word of Life can be terrifying.
Like snow tubing.
Yeah, I flipped off my tube. So
Are we doing that? Or are we just skiing?
probably. Oh no, at Word of Life they don't ski at Word of Life.
I want a tube. That's what I want to do.
It's fun, but you have to walk yourself up to the top with your tube because it's not
It's
like this
going
like
up
automated
mountain
place.
pipelines.
Pretty much, but snowy.
Snow edition.
Yeah. If it's a lot of snow there, they may let you
Like right up.
no. They may let you do jet skiing but on the snow.
Oh, that'd be so
What is that
fun.
thing called?
The snowmobile?
Yes, that. We
Yeah.
got to do that 2 years ago, but last year there wasn't snow for it.
I think we're gonna have snow. Mr. Law was telling us that one day we're there, it's gonna be a high of like 21. and
Okay,
it's
but I'm
gonna
also
be
going to
cold.
tell you 21 in New York feels very different than 21 here. 21 in New York is actually kind of warm.
Okay, I was about to say, I thought you were gonna
Is
say
it
it's
more
like so
humid
much worse.
there or something?
No, it's way more humid here, so that's why it's colder here.
Oh, because damp air.
Yes.
Damp air.
So, like, obviously, if it's presently snowing, yes, it's going to be cold. But it actually, not last year, the year before, it actually snowed while we were skiing. Yeah. It was
Watching
interesting.
this video in the future will be very confused.
Well, it's always around senior trip time, so probably not.
No, I
Anyways.
mean, like
I'm
the random
probably-
people who have to
Oh.
watch your videos.
I'm probably gonna
Yeah.
come back from senior trip like sick or something. Like, it just from being
Why
in that weather.
would you have to say that?
Well,
But, like, a lot of people, we don't, usually doesn't happen like that, though. Like, yes, it is a drastic difference from here, but at the same time, it's not. Like, I don't know how to explain it. It's cold, but it's not. And it's very different because it's not a damp cold, even when it's snowing or raining, because we've been there when it rained, too. So, Yeah.
I'm
I
excited
feel like
to go.
The Word of Life Day can be, it is what you make it. So, like, if you enjoy, like, if they, I don't know if y'all get to do paintballing. 2 years ago, we got to do paintballing. Last year, we didn't. But we didn't really go to Word of Life last year for more than, like, because there was no snow, there was nothing to do. So, like, Word of Life, because it's basically closed during the time that we're there. So, it was, like, not a lot to do. But
Yeah. I
it
don't
was
even know what day
fine,
we're
but-
doing that. All I know is
a lot of times it ends up being Wednesday.
Yeah, Thursday is the like Hershey Park. Monday is I don't even know actually.
Yeah.
I have a picture of it on my
I feel
phone.
like it's just gonna go by super fast, and like we'll get there, and then we're coming
Like
back.
a week seems like a long time, but I feel like it's gonna go by really
The
quick.
fact that we're like starting to come back on Thursday.
You'll get back before school's out on Friday, but, like, you won't come to school.
Because I remember last year they were getting here as we were getting out of school.
Yeah.
And I was like, how are they here so early? Like I was expecting them to get here late.
Yeah.
Unless some sort of like Maryland trip thing happens. That would be
Yeah.
Don't ask why I said it like that.
It's a good time, though. Like,
Yeah.
y'all have fun. And, like, y'all are actually old enough to be in the hot tub at the
How
pool.
old do you have to be?
You have to be 18.
Yes. Some of us can go in, some of us
Okay, but, like, look, I'm going to tell y'all this. You can share it if you want. They don't really check. If they do check, then you can be like, I'm 18, and they don't really ask any questions.
Like, let me see her.
The year that I was on my senior trip, so I didn't turn 18 till college. Like, I was in college when I turned 18. And so I was, what is happening? This whole thing is glitching. So they didn't even ask me how old I was, but some of the people that were goofing off, they did ask them how old they were, and they got kicked out.
Were any of them 18?
No. There were only like 3 people that were 18 on our trip.
That's how it is for.
And one of them wasn't 18 at the start of our trip, but at the end of the trip they were.
Is that the one who got the piercing?
Yeah, well, there was 2, so yes. I guess technically there were 2 because one of them's birthday is the 4th and one's the 5th. So.
Right. I think everyone in our class is going.
Yeah, I heard as of yesterday that everybody is.
Yeah.
So. We wouldn't.
Oh, Josh is concerned about where he's gonna sleep at night.
Yeah.
Why?
I don't want to be in a bed with another guy.
The pull-out couch is really comfy.
Right, but there are 4 people in the room, so someone's gonna have to sleep with someone.
Well, James and Jaden already said that they would.
Cool. I wouldn't mind taking the couch. I can bring a blanket.
I love blankets. A lot of numbers.
I wanna.
This is actually a word problem. The whole reason that's about a bobsled. That's why the whole thing started. It was relevant to the problem.
It goes with the problem.
It does. I'm just not writing the whole problem out. This table, and they gave you the table up and down, but I did it side to side, so it didn't take up so much room. Anyways, records the velocity of a bobsled at 1 second intervals. Notice 1 second intervals. For the first 8 seconds of its run. Use the trapezoidal rule to approximate the distance the bobsled travels during that 8 second interval. Give your final answer in feet.
Girl,
Did you just say girl what?
what? Yes. 5,280 feet or in a mile, right? Right. So. Ew.
Okay.
A lot of numbers.
So, we got to make sure we watch units.
Big
All right.
numbers. It's like it's a water. Her C has a little loop to it, so it looks like an E.
The width is
It
1
looks even more
second
like an E now.
because there's 1 second between each of these.
No, it's really water.
Now, we also have miles per hour, meaning h is in hours. But we need seconds. So what does that mean?
We need to multiply all those numbers. We need to.
By what, Virginia?
Well, she shook her head no, so that's not the answer. You take this one, Josh.
How many seconds are in an hour?
Oh, 3,600.
3,600 seconds in an hour.
1940 is minutes in
So that means that h is 1 over 3,600. So then t is 1 over 3,600 over 2. I'm going to rewrite this, though, and go ahead and call this 7,200 so that I don't have to rewrite this all a million times. So 1 over 7,200 times 0 plus 2 times 3 plus 2 times 7 plus 2 times 12 plus 2 times 17 plus 2 times 25 plus 2 times 33 plus 2 times 41 plus 48. I got it. It was a struggle, but I got it. So 1 over 7,200 times 6 plus 14 plus 24 plus 34 plus 50 plus 66 plus 82 plus 48.
How many
Also,
more steps until we get to the answer?
Depending on how many lines you take to write it, 2 or 3.
Okay, because I only have one line left after this.
Well, you can do all this in one step.
Cool.
6 plus 14 plus 24 plus 34 plus 50 plus 66 plus 82 plus
got this.
48 divided by 7,200 is 0.045. Now, keep in mind, this stuff was in miles because it was miles per hour. But I need feet. So what do I need to do?
Multiply by 5,280.
I'm so glad we don't have to worry about significant figures.
So that's our feet.
Ow. Stabbed myself.
All right, so the trapezoidal rule is what we've been using up to this point. The next ones want us to use Simpson's rule. So what you're going to notice in all of the problems, 1 through 6 and 13 through 18, they are the exact same problems. One you do with the trapezoidal rule, one you do with Simpson's rule. So typically, what I have done on a quiz or a test is I have just said to use trapezoidal rule and Simpson's rule to solve, and we're trying to see which one's more accurate, essentially. So when I'm about to do 14, it will be the same as number 2.
Cool. Hold on, let me write my
Now, these ones also say find the exact value of the integral to check your answer. Since we've already done that with 2, I won't do that part on this problem. But just know, like, if I assigned you 15 and not number 3, then you should do that, if that makes sense. So, the integral from 0 to 2 of x squared dx, and we're still using n is equal to 4. So you find h the exact same way. It's still 2 minus 0 over 4, or in this case, 1/2. So my intervals will be just like they were in number 2. So obviously we've already set this one up. And I'm going to do one more of these as well so that you guys can see it. I'll probably do it with trapezoidal and with Simpsons as well, depending on where we're at time-wise here because we're getting close. So 0, 1/2, 1, 3/2, and 2. This was 0, 1/4, 1, 9/4, and 4. All right, so Simpson's rule is h over 3. So S equals 1/2 divided by 3 times the first number, which is 0 in this case, plus it's 4 times the next number, plus 2 times the number after that, plus 4 times the number after that. And those keep alternating in those middle terms. But the last one is always just whatever the final number is. So this will be 4 times 1/4 plus 2 times 1 plus 4 times 9/4 plus 4 there at the end. So this is 1/6 times 1 plus 2 plus 9 plus 4. So then that ends up being 2.66 repeating. Now, all the way back to number 2, what did the trapezoidal rule tell us this was equal to?
2.75.
2.75. And what did our exact integral tell us it was equal to?
2.66 repeating.
Yep. So, Simpson's rule typically is more accurate than trapezoidal. Not always, but typically it does come out to be more accurate. So,
The
just
Simpson ones can only be used for n is even. Right?
yes, yep.
So if n is
Like
odd,
5.
You couldn't use Simpson's rule then,
then you have to do
because it's pretty much always going to be, well, because of the way that this has to work, the numbers alternating in there. That's why it has to be that way.
But trapezoidal can be used for like any odd or even.
As far as I remember, let me look and make sure. I don't see anything that says. Yeah, just n subintervals. The other one says into an even number of n subintervals. So yeah, trapezoidal can be for any. So, like I said, trapezoidal can't be used for everything. But in this case, they have n equals 4 on both. So,
it can be used for n.
All right, another Simpsons rule, and then I may go back. This is also number 6 as far as trapezoidal, but we didn't do that one yet. But 18, the integral from 0 to pi of the sine of x dx. So n equals 4, and I'm from 0 to pi. So that means that h is equal to pi minus 0 over 4, or just pi over 4. So looking at my table, increments of pi over 4, we would be 0, then pi over 4, then pi over 2, then 3 pi over 4, and then pi. So this is another time when your unit circle would come in handy to make sure you remember that as well. So the sine of 0 is what?
0.
Sine of pi over 4?
Square root of 2 over 2.
Yep. Pi over 2?
0.
1.
1. I knew that.
3 pi over 4?
Anything. -1. Wait.
Root 2 over 2.
Root 2 over 2.
Oh my goodness.
All the ones that have a 4 on the bottom are root 2 over 2.
Okay.
And then pi?
For cosine.
0.
0. So then now, S equals pi over 4 divided by 3. I'm going to go ahead and rewrite this as pi over 12, just so that I don't have to write it all out a second time. So then I've got 0 plus 4 times root 2 over 2 plus 2 times 1 plus 4 times root 2 over 2 plus 0. So pi over 12 times 2 root 2 plus 2 plus 2 root 2.
How did you get the times 12?
Pi over 4 divided by 3.
You just playing the 4 from the 5 when you just make it hang out to 3 as well. Interesting. I know, right?
And so this gives me 2.005 rounded. Now, just to see if I actually did this integral here, what's the antiderivative of sine?
Cosine. I mean, oh my goodness. Wait.
Come on, Virginia. You
What's
got
the
this.
derivative of cosine?
Negative sine. Wait, no. Sine.
Negative sine.
Negative
So it would
sine.
need to be negative cosine.
Okay.
Evaluated from 0 to pi. So what is the cosine of pi?
Negative 1.
-1, and since this was a negative, this would be a +1 minus cosine of 0,
0. 1.
so +1. There we go. So that ends up being 2.005 compared to 2. Pretty accurate. Now, you could do the trapezoidal one with it relatively quickly, and it'll come out to be relatively similar. I'm going to go ahead and give you your problems, because that way tomorrow, if y'all have questions, you can ask about them. So let's see. I'm going to give you, and I'm going to pair them with what they go together. So 3 and 15. And so, like, what I would do is when you do 3, I would also do 15. Because that way you can do trapezoidal and Simpson all together, and that way you can also compare them. So do all the stuff that it says for trapezoidal, and then just also do Simpson. And then 5 and 17.
I'm using parentheses to group them together.
And then 7 and 11. So 7 will be like 8, and 11 is like 12. So I know they're kind of out of order, but
So are 7 and 11 a pair?
no.
Okay.
Just 5 and 17 and 3 and 15.